Let us look at another example of cost volume profit analysis. A television manufacturing company manufactures and sells three different types of televisions. Revenues and costs for each type of television are given to us in this table. So we have three different types of televisions: television A, television B, and television C. Now for television A, the sales revenue is $50,000. For television B, the sales revenue is $90,000. And for television C, the sales revenue is $60,000. Now the variable cost for television A is $40,000. The variable cost for television B is $60,000. And the variable cost for television C is $42,000. Now we know that sales minus the variable cost is the contribution margin. So the contribution margin for television A is 50,000 minus 40,000, which is 10,000. And also, since the sales revenue is considered as 100%, and out of this 100%, 80% is variable cost, the remaining 20% is contribution margin. Now for television B, the sales revenue is $90,000, which is considered as 100%. The variable cost is $60,000, which is 2/3 of the sales revenue, and 2/3 means 66 2 by 3rd%. The contribution margin for television B is 90,000 minus 60,000, which is $30,000, which comes out to be as 33 1/3%. Now for television C, the sales revenue is $60,000, which is 100%. Variable cost is $42,000, which is 70%. And the contribution margin is given to us as $18,000, which is 30%. So $60,000 minus $42,000, which is $18,000, and 100 minus 70, which is 30%. Now we have been given the sales mix. That means of the total sales revenue that the company makes by selling these three types of televisions, the ratio of sales revenue from television A is 25, the sales revenue ratio from television B is 45, and that from television C is 30. So let's find out how we get this. So the sales revenue from television A is $50,000. The sales revenue from television B is $90,000. And the sales revenue from television C is $60,000. So here we can remove these 4 zeros as it is common for all these three terms. So it becomes 5:9:6. So this is the ratio in which these three televisions are selling. Now if we have to convert this ratio in terms of percentage, that means out of a total of 100, how much portion is the sales of television A, how much portion is the sales of television B, and how much is the sales of television C. So for television A, the portion of sales out of the total sales is 5 divided by the total, which is 6 plus 9 is 15 plus 5 is 20. And this we want to find out of a total of 100. So 25s are 100. So this becomes 5 multiplied by 5, which is 25%. For the second one, it is 9 divided by again the total of the 3, which is 20, multiplied by 100. So this is equal to 9 5s are 45%. And for the third one, which is television C, we have 6 divided by a total of 20 multiplied by 100. So this becomes 5. So this is 6 5s are 30%. So A is 25%, which is this, B is 45%, which is this, and C is 30%, which is this. So this is how we have arrived at the sales mix here. So with this information given to us, we are supposed to find out the following. The first, compute the break-even point in sales for the company, assuming that the fixed costs total $34,800. Second, compute the break-even point in sales for the company, assuming that fixed costs and total sales remain the same and that the sales mix is 50% of television A, 30% of television B, and 20% of television C. So let us try and understand this example in a little more detail. So let's say that these are the three types of television that the company is selling. Now, out of the total sales revenues, television A has a sales revenue of $50,000. Television B has a sales revenue of $90,000, and television C has a sales revenue of $60,000. Now, in order to manufacture these different types of televisions, the company needs raw material and labor. This cost of raw material and labor is known as the variable cost. And it is known as variable cost because it depends on the number of units that are being produced. So the variable cost has also been given to us for these three different type of televisions. For television A, the total variable cost is $40,000. For television B, the total variable cost is $60,000. And for television C, the total variable cost is $42,000. Now we know that sales minus the variable cost is the contribution margin. So the contribution margin for television A is 50 minus 40, which is $10,000. For television B, it is 90,000 minus 60,000, which is $30,000. And for television C, it is 60 minus 42, which is $18,000. Now we have also been given the sales mix, which is the relative sales of each of the television types. So out of the total sales of television, the sales of television A makes up for the 25% of sales revenues. Television B makes up for 45% of the sales revenues, and television C makes up for 30% of the sales revenues. Now first we have to find out the break-even point in sales for the company, assuming that the fixed cost totals $34,800. Now, in order to manufacture these televisions, there are some fixed costs like the manufacturing facility, which is being used as a factory. So the total fixed cost for all the three has been given as $34,800. And we have to find out the break-even point in sales. That means how much sales should the company do in order to have a no profit, no loss situation. So let's find out the answers for these questions. So the information provided to us has been mentioned in these three boxes representing television A, television B, and television C respectively. Now the first question is to compute the break-even point in sales. So compute the break-even point in sales for the company assuming that fixed costs total $34,800. So this fixed cost is the fixed cost for the entire facility which is being used to manufacture television A, B, and C. And we want to find out the break-even point in the total sales. Now we know that the break-even point is the point at which there is no profit and no loss, or in other terms, the total revenue is equal to the total cost. Now total revenue is quantity multiplied by the unit selling price, and total cost is fixed cost plus the variable cost, which is quantity multiplied by the unit variable cost, or Q multiplied by P minus Q multiplied by C is equal to F, or Q into bracket P minus C is equal to F, or Q is equal to F divided by P minus C. So this is the quantity at which the total revenue will be equal to the total cost. Now if you want to find out what is the break-even point in terms of sales, then we have to multiply this Q by P, because Q multiplied by P will be the total revenue. So or Q multiplied by P is equal to, now if we multiply P on the left hand side, we have to multiply the right hand side also with P. So F divided by P minus C multiplied by P, or now this is the break-even point in terms of revenue, which is equal to F. Now P minus C is the contribution margin, or I would say the unit contribution margin, and this P can be brought down, and if we bring it down, it will be UCM divided by P, and this is also known as the contribution margin ratio, or the contribution margin percent. So or our break-even point in terms of revenue is equal to fixed cost divided by the contribution margin percentage. Now in this case, we have been given the total fixed cost. However, we have different contribution margins for each of the product types. Hence, what we can do is that we can find out the weighted average contribution margin percentage and then use that in this formula. So weighted average contribution margin percent will be equal to, so basically here we'll add all the contribution margins and then divide them by the total sales revenue. So this becomes 10,000 plus 30,000 plus 18,000 divided by the total revenue, which is 50,000 plus 90,000 plus 60,000. So 18 plus 30 plus 10 is 58. So 58,000 divided by 90 plus 60 is 150. 150 plus 50 is 200. So 200,000. So this becomes 0.29, or in other terms it is 29%. So now we can use this in the formula for break-even point. So break-even point in terms of revenue is equal to the fixed cost, which is 34,800, which is given here, divided by the contribution margin ratio or the contribution margin percent, which is 0.29. So this is equal to $120,000. So this is the break-even point in terms of revenue. So what this means is that the total sales combined for A, B and C should be $120,000. Now we are already doing a sales of $200,000, which is much more than $120,000. So that means we have already surpassed the break-even point and are currently making profits. Now if we have to find out the individual break-even points for A, B and C, then we just have to take out the sales mix percent from this break-even point. That is 25% of $120,000 is the break-even point in terms of revenue for television A. 45% of $120,000 will be the break-even point revenue for television B, and 30% of $120,000 will be the break-even point revenue for television C. Now let's move to the next part, which is part number 2. So the second part is to compute the break-even point in sales, assuming that the fixed costs and the total sales remain the same, and that the sales mix is 50% of television A, 30% of television B, and 20% of television C. So basically the total fixed cost was given to us as $34,800, which is the same, and the total sales is 50,000 plus 90,000 plus 60,000, which is $200,000. Now what is changing is the sales mix. So out of this $200,000, the sales revenue from television A was 25%. The sales revenue from television B was 45%. And the sales revenue from television C was 30%. Now it is going to be 50%, 30%, and 20%. So now with this sales mix, all these values will change for each of the television types. So let's recalculate these values based on the percentage that was given to us for the sales revenue, variable cost and contribution margin for each television. So the sales revenue now is 50% for television A. So what that means is, out of a total sales of $200,000, the contribution television A is $100,000. Now out of the total sales revenue of $100,000, we were given that the variable cost is 80%. So this becomes $80,000, and therefore the contribution margin is now $100,000 minus $80,000, which is $20,000. For television B, the sales mix is now 30%. So the sales revenue is 30% of $200,000. 30% of $200,000 is $60,000. The variable cost was given as 2/3 of the sales revenue, or 66 2/3%. So 2/3 of 60,000 means 60,000 divided by 3, which is 20,000, multiplied by 2, which is 40,000. So the variable cost is $40,000, and the contribution margin will be the sales revenue minus the variable cost, which is $20,000. For television C, the sales mix is now 20%. So 20% of 200,000 is $40,000. Now the variable cost was 70%. So 70% of 40,000, 7 fours are 28. So this becomes $28,000. And the contribution margin is 40 minus 28, which is $12,000. So now with these new numbers, we have to find out the break-even point in terms of revenue. Now, as we had seen earlier, the break-even point in terms of revenue is equal to fixed cost divided by the contribution margin divided by the selling price. And since we have a multi-product company, we'll have to take the weighted average of this term. So in this case, again, we'll have to calculate the weighted average contribution margin percentage. So weighted average contribution margin percent is equal to, so the weighted average contribution margin will be equal to unit contribution margin multiplied by the number of units. This is for product A, plus the unit contribution margin multiplied by the number of units for product B, plus the unit contribution margin multiplied by number of units for product C, divided by the total number of units for A, B and C. So numbers for A plus number of units for B plus number of units for C. Now this part is just the weighted average of the contribution margin. Then we have to divide this by the weighted average of the selling price. Now weighted average of selling price will be the unit selling price for A multiplied by the number of units sold for A plus unit selling price for B multiplied by the number of units sold for B plus the unit selling price for C multiplied by the number of units sold for C divided by the total number of units sold, which is A plus B plus C. And this overall is the weighted average contribution margin. So this should be here. Now in part number A, what we had seen was a narrowed down version of this formula, because this denominator gets cancelled with this denominator. So what we had seen was unit contribution margin A multiplied by the number of units for A plus unit contribution margin B multiplied by number of units for B plus unit contribution margin for C multiplied by the number of units for C divided by unit selling price for A multiplied by the number of units of A plus the unit selling price of B multiplied by the number of units of B plus the unit selling price of C multiplied by the number of units of C. Now what is this? Unit contribution margin for A multiplied by the number of units sold for A. So this means the total contribution margin for A, which is nothing but this number here. Similarly, for B, this is the total contribution margin, and for C, this is the total contribution margin. And what is this? So this is the unit selling price multiplied by the number of units sold for A, which is nothing but the sales revenue. So sales revenue is the number of units sold multiplied by the unit selling price. So if we substitute these values, we get 20,000 plus 20,000 plus 12,000 divided by 100,000 plus 60,000 plus 40,000, which is 200,000. And this is equal to 20 plus 20 is 40 plus 12 is 52. 52,000 divided by 200,000, which is equal to 0.26. So this is the contribution margin percentage. Now let's substitute this value in this formula to obtain the break-even point in terms of revenue. So fixed cost is 34,800 divided by the contribution margin percentage, which is 0.26, and this is equal to $133,846. So $133,846. So this is the break-even point in terms of revenue for the entire company. So this is the break-even point in terms of revenue for the entire company. And if you want to find out the break-even point for each of these product types, then we have to find out the ratio, which is 50% of 133,846, 30% of 133,846, and 20% of 133,846.